F650 relay can communicate with a PC through two different protocols, RS-232 for older models or USB for newer ones. In this chapter, we shall see how to configure and establish communications in order to be able to send and receive information to and from the relay. How to connect a PC to the F650 using RS-232. Now we will learn how to establish communication between an F650 relay and a PC via the front serial RS-232 port. This serial port is available on the older relay models. A straight-through DB9M serial cable has to be connected between the front plate of the relay and the computer. In the EnerVista 650 setup software, navigate to Communication, Computer, and a window will appear where the computer settings will have to be set. Make sure that these settings match the ones on the relay in order to be able to communicate. These settings can be found on the relay menu using the shuttle key on the older relay models and on the PC as follows. In the Control Type field, choose which type of communication will be used. Choose No Control Type in order to communicate via the serial port. The slave address, which is the Modbus slave address of the relay, can be found by navigating the HMI of the relay to View Settings, Product Setup, Communication, Modbus Protocol. The communication port is the serial communications port of your PC. The baud rate and the parity are both in the menu View Settings, Product Setup, Communication, Serial Ports. The Startup mode defines how the user wants the F650 to start up. If choosing the startup mode to be Communicate with Relay, the EnerVista 650 setup will try to automatically communicate with the last relay it was connected to. If choosing File mode, the 650 setup software will not try to communicate automatically and will start in offline mode. Once these parameters are set, communication is ready to be established. Press the Communication On button in the lower part of the window. Once the communication has been successfully established, a message saying F650 setup is now talking to F650 will appear. The communication can be interrupted by pressing the Off button. How to connect a PC to F650 using USB. The USB front plate communications port has replaced the RS-232 port on the newer models. If the relay has a USB connection on the front plate, use this guide in order to communicate between an F650 relay and a PC. Use a male A, male B shielded USB cable to be connected between the relay and the computer. In the EnerVista 650 setup software, navigate to Communication, Computer on the main menu, and a window will appear where the computer parameters will have to be set. Make sure that these settings match the ones on the relay in order to be able to communicate. These settings can be found on the relay menu using the Up, Down, Enter, and Escape buttons, and on the PC as follows. The slave address can be found in the menu View Settings, Product Setup, Communication, Modbus Protocol. The communication port is the one that belongs to your PC. The baud rate and the parity are both in the menu View Settings, Product Setup, Communication, Serial Ports. In the Control Type field, no control type shall be chosen. Once these parameters are set, communication is ready to be established, so we shall press the Communication On button in the lower part of the window. When the communication is established, a label will appear above the status bar stating F650 setup is now talking to F650. The communication can be interrupted by pressing the Off button next to the On button. Given that relays usually work in networks, it is essential to be able to change the F650's Ethernet configuration. This task can be achieved either directly through the front plate of the relay or by using the F650 setup software. Changing the Ethernet configuration directly on the relay. The settings that can be changed in order to configure a network are the IP address, the Modbus port, and the unit identifier, also known as Modbus address or slave address. These settings can be reached by navigating through the main menu in the relay as follows. The IP address can be found in Change Settings, Product Setup, Communication, Ethernet. The Modbus port number can be changed in Change Settings, Product Setup, Communication, Modbus Protocol, Modbus port number. Finally, the Modbus address setting is located at Change Settings, Product Setup, Communication, Modbus Protocol, Modbus Address. Once these parameters are set, press the Enter button or the shuttle key. This way the setting will be selected. Change it using the up and down buttons or by pressing the shuttle key. Once the selected setting is changed, deselect it by pressing Enter or the shuttle key again. Press the Escape button to go a step back in the menu. A window will appear with the message, Press Enter to save settings. Once this is done, the new setting will be saved. Alternatively, press the Escape button again if you do not want to save this change. Changing the Ethernet configuration from a PC. In order to change the Ethernet settings using the EnerVista 650 setup software, the relay must be connected to a PC via USB, serial, or RS485 ports. Navigate through the main menu on the EnerVista F650 setup software following these steps. The IP address, netmask, and gateway IP can be found in Setpoint, Product Setup, Communication Settings, Network, Ethernet. The Modbus address and Modbus port number can be changed in Setpoint, Product Setup, Communication Settings, Modbus Protocol. When these addresses are selected on the menu, a window with some tables, which include the mentioned settings, will appear. Change these settings by selecting the corresponding fields in the tables and entering the values with your keyboard. Once the settings are changed, press the Store button in order to send the changes to the relay. After that, exit this menu by pressing the OK button. Connecting a PC to F650 using Ethernet. To establish communication between an F650 relay and a PC via the rear Ethernet port, there are two different options. For direct PC F650 connection, a crossover 10-base T cable is required. Alternatively, if we wish to use a straight-through 10-base T cable, a network switch will be required between the PC and the relay to perform the crossing. Once the wires are connected, using the EnerVista 650 setup software, navigate to Communication, Computer. In the new window, make sure that these settings match the ones on the relay in order to be able to communicate. First, on the Control Type tab, the option Modbus TCP has to be selected. Once this is complete, the settings on the window will change if the Control tab had previously been on No Control Type. The settings on the Modbus TCP setup panel are the ones that have to be configured. The relay IP address can be found in the menu View Settings, Product Setup, Communication, Ethernet, Ethernet 1.2. Note that 1.2 refers to the main Ethernet port, while the 2.2 refers to the redundant one if your relay has it. The Modbus port number and the unit identifier, which is the Modbus address, are found under View Settings, Product Setup, Communication, Modbus Protocol. In order to be able to communicate, the following considerations must be completed. The relay IP address and the computer IP address must be different, but both subnet masks must be the same. This way, both elements are identified as different elements in the same network. For more information concerning which IP addresses to use, refer to your network administrator. And finally, in the Startup Mode tab, Communicate with Relay shall be chosen. Once this is done, the communication is ready to be established by pressing the Communication On button in the lower part of the window. When the communication is established, a label will appear above the status bar stating that F650 setup software is now talking to F650 and the PC will be communicating with the relay. The communication can be interrupted by pressing the Off button next to the On button. Once the Ethernet configuration is complete, we are ready to connect our relay to a network. The F650 relay can have up to 2 Ethernet ports. Each one of these can be either copper or fiber optic and are connected to the CPU through a switch. Even though the relay may have 2 Ethernet ports, it can only communicate through one at a time. These 2 Ethernet ports can be connected to redundant networks or to independent networks. Whichever the case, the relay will only be able to communicate through one of the ports at a time, and this must be taken into consideration. The F650 relay can run in the following network configurations or local area networks. 1. Star topology. In this topology, the relays are connected to a switch. The user can access any relay by connecting a computer to this switch. 2. Redundant star topology. The redundant star configuration is the same as the simple star, but doubling the network for security. Each relay will only be able to communicate through one star network at a time. 3. Ring topology. In this network configuration, there are usually many switches connected to one another, forming a ring. Then the relays are connected to the switches. If the relay has 2 Ethernet ports, it can be connected to 2 different switches for security in case one way of communication breaks down. In this case, we must remember that only one communication port will be operative at a time. If there is an old F650 relay without an Ethernet port, it is possible to connect the relay to the network through a serial port using a serial Ethernet converter. One option is to use the GE Multilin Multinet serial converter, which converts the serial RS485 protocol to Ethernet. Multinet is a communications module that provides GE Multilin serial Modbus IEDs with Modbus TCP/IP communications over Ethernet, allowing connection to fiber optic LAN and WAN network systems. Multinet has the capability to connect up to 32 serial Modbus devices, eliminating complex wiring and additional communications converters, and providing a streamlined and economical Ethernet hub. Unlike most communications converters that are designed for commercial use, Multinet is environmentally hardened to withstand severe utility and industrial conditions. The web server in the F650 can be accessed by typing the relay IP address in any Internet browser. The main screen of the F650 web server shows the different monitoring possibilities for the snapshot events, alarms, oscillography, fault reports, data logger, and metering values provided by the relay through the web. To access the web server, connect your PC to your relay via Ethernet and type in the IP address of the relay into your browser. In order to access the different functions provided by the web server, simply click on the list name on the left side of the screen. Let's take a look at each of the menu items. The Snapshot Events screen shows all snapshot events produced in the relay. This screen is refreshed automatically every minute. The information provided in this screen includes the relative event index, with the lowest index corresponding to the most recent event, the event text that shows the reason for the event, the event status as active, on, or inactive, off, and finally, the date and time when the event was produced. The bottom of the screen shows a metering screen. Clicking on one of the events, the associated metering values will be shown on this screen. The Control Events screen provides access to all events that have been configured in the Control Events screen inside the Relay Configuration menu of EnerVista 650 setup software. Unlike the snapshot events, in this screen, the highest index corresponds to the most recent event. The information provided is the Control Event Index, the text that has been associated to each event when configured, its status as active, on, or inactive, off, and its date and time. The Alarms screen provides access to alarms configured in the relay. As was the case for the snapshot events and control events, this screen only allows viewing the alarms, but not acknowledging them. The oscillography screen allows the user to obtain from the relay available oscillography records in that moment. This screen includes 2 windows. The first window shows the oscillography records available in the relay, identified by an index where the highest index is the most recent record. If the user clicks on the oscillo record he or she wants to retrieve, the window on the right will show a description of the record header, indicating its date, time, and the most relevant parameters of the record. Once a record is selected, pressing the Download button will allow the user to save the files in ComTrade format on the PC hard drive. After saving the record, the system will ask if the user wants to open the GEOSC tool, which is a ComTrade record viewer, to view the downloaded files. Clicking on the Home option, the system will return to the web server main screen. The Fault Report screen provides access to the last 10 fault reports obtained by the relay. These records are stored according to an index that marks their position among all records produced in the relay, with a range from 1 to 999, returning to 1 in case of exceeding the limit of 999. As was the case with the oscillography records, the highest index corresponds to the most recent record. The information provided in this screen includes the date and time when the fault was registered, fault calculations such as distance to the fault, type of fault, date and time, and the line parameters, as well as the recloser and breaker status during the fault. This screen also shows pre-fault and fault voltage, as well as current primary values. At the top of the screen, associated with the trigger event number, there is a button labeled Info. This button displays the events produced before and after the fault report trigger so that the user has very useful information about the moment when the fault was produced. To obtain a text file with all the fault report information, press the Download option and save the file in the computer. The Data Logger screen displays the date and time of the first and last values retrieved from the relay. It also allows the user to download the data record files in ComTrade format by pressing the Download option. Stored files can be viewed later using any ComTrade format viewer. And finally, the metering screen includes the 53 primary metering values provided by the relay display. In this section, we'll take a look at how to troubleshoot Modbus integration issues. We'll start by learning how to gain access to F650 data using the Modbus RTU protocol. F650 relays have a generic database compatible between all versions, no matter their type or configuration. This database is organized by groups, such as status or setting groups, and all items in it are described, explaining their data type, length, memory position, etc. Each object in the database has a unique memory position, and as new objects are added in new versions, they are added in further addresses, keeping the previous items fixed in the addresses they were set in. It is possible to get the memory map using EnerVista 650 setup software. To do so, follow on the main menu the address View Modbus Memory Map. Traces and Troubleshooting. The F650 setup software provides a tracer, which is a debugging tool to view the strings in any reading or writing process in Modbus. To activate the tracer, go to View Traces. For example, the user can see the request and response strings interchanged between the PC and an F650 relay. To do this, first, activate the tracer as we have just explained. Two windows will appear on the lower part of the screen. Next, open the General Settings menu. The screen will display the active setting group. On the bottom left side, the relay reading request will appear, and on the right, the settings response will be shown. There is another tool for tracing the relay memory found under Communication Troubleshooting. Using this tool, any value at any address can be requested, or any value can be written in any address. This window is divided in two panels, one for requesting information, the Memory Map Inspection panel, and one for writing information, the Memory Map Insertion panel. Both of these panels work in a similar fashion. First, in the leftmost column, tick the checkbox to activate the respective row. Then enter the memory address. Next, depending on which tool is being used, select from the tabs the data type and format and write down the number of elements you wish to visualize. The result will be shown in the Values column. In this section, we shall see how to upgrade the firmware and the operating system in our F650 relay. Before doing so, it is essential to understand the following considerations. When upgrading the firmware in the relay, all the settings and configurations will be lost. Therefore, it is advisable to save these to a file before starting the process. To do so, go to File, Get Info from Relay. In the window, you will be able to save the .650 file with all the settings and configurations to your PC hard disk. For firmware revisions lower than 1.50, it is required to save the calibration settings in a file before upgrading the F650 to a new firmware version. Go to Communication, Calibration, Get Calibration Settings to open a navigator to save the calibration settings. For firmware revisions higher than 1.50, it is not necessary to save the calibration files when upgrading the firmware since they will not be modified. Special care must be taken when the bootware is upgraded, since all the information in the relay is lost when this is done. In case of error during the firmware upgrading process, the user can repeat the whole process as many times as necessary. This is possible thanks to an independent boot memory, or boot code. The firmware upgrading process is completed using the EnerVista 650 setup software with an Ethernet connection, COM3, via crossover RJ45 Ethernet cable. Firmware Upgrade. We shall now learn how to upgrade the firmware in our F650 relay. We shall do this by downloading the new firmware file from our PC to the relay. Therefore, we need to be in possession of the new firmware files we want to install. Download these from www.gedigitalenergy.com or request them at any GE Multilin utility. Connect the Ethernet cable. Check the relay and the computer communication. Remember, both elements must have different IP addresses and the same subnet mask. Once you have checked that the communication ports work, interrupt the communication. There must be no active communication between the computer and the relay before starting the firmware upgrade process. This means, once you have checked that the communications work, go to Communication, Computer, and press the Off button. Remember to get the settings, configuration, and calibration files, if necessary, from the relay before starting. Let's begin with the firmware upgrade. Navigate to Communication, Upgrade Firmware Version. A window will appear reminding the user that all information in the relay will be lost and that firmware and bootware versions must be compatible. Click the Yes button. Then another window will appear requesting the relay serial number, IP address, and order code. Fill in the gaps and select the order code from the tabs. Once this is complete, press the Upgrade Firmware button. If, when clicking on the Upgrade Firmware button, an advise message is given stating communications failure, local network reboot is necessary. Proceed as follows. Go to Startup, Control Panel, Network Connection, Local Network. Right mouse click, Disable. Now the local network status will be shown as disabled. In the same screen, with a right mouse click over Local Network, click Enable and wait until the enabled status is shown. Then press the Upgrade Firmware button to continue the process. When upgrading models with enhanced protection or control functionality, the program will request a password to continue. In case you have a special functionality model with password requirements, please contact GE Multilin and include the following parameters in the order: unit serial number, current model option before memory upgrade, desired model option after memory upgrade, and unit MAC address, available in the identification label. After entering the upgrade parameters and pressing the Upgrade Firmware button, a window will ask you to reboot the relay and to select the update.txt file, which is part of the firmware file you must acquire in advance. Reboot the relay and select the upgrade.txt file, pressing the button with the 3 dots and using the dialog box that will appear. Another window will appear stating the voltage range that will be used. Do not change the automatically selected option since this is related to the relay serial number. Click the OK button. In the next window, agree to start the update of the firmware. During the process, the program displays the files that are being updated. When the file transfer is finished, a message will appear stating that it is necessary to wait some time before resetting the unit in order to start working with the new firmware version in the relay. When the whole process is finished, a message will be displayed asking to switch the F650 off and on. Click OK. At this point, the firmware upgrade procedure is finished and the relay is ready to be powered off and on to check that the firmware has been upgraded properly. Finally, the relay is ready to receive the user settings and logic files. Upgrade operating system. The boot code upgrade is performed using EnerVista 650 setup software. There must be no active communication between the program and the relay, and no configuration file can be opened. During the boot code upgrading process, all the data stored in the relay will be lost, so it is necessary to save all calibration, settings, oscillography, etc. from the relay before the upgrade. It is extremely important to save the relay settings and calibration before continuing with the process. First of all, we shall acquire the new operating system file we want to install. This can be downloaded from www.gedigitalenergy.com or requested at any GE Multilin utility. To upgrade the boot code, it is necessary to connect our computer and the relay through serial and Ethernet connections, both at the same time. Go to Communication, Computer, and set the settings so as to communicate through the serial port, either USB or RS-232. Press the Store button. Start the EnerVista F650 setup program and at the top menu bar, choose Communication, Upgrade Operating System. A window will arise reminding you to save the calibration settings before upgrading the operating system. Click Yes to proceed with the upgrade process if all the necessary information from the relay has been saved. Another reminder will turn up telling you that all the information in the relay will be lost. Click Yes to proceed with the process. A third warning will appear to make sure that both serial and Ethernet connections are set as explained before. Click Yes to go on. In the next window, select the network adapter for your Ethernet connection to the relay. Select the correct one in case you have more than one and click OK. After selecting the network adapter, a window to choose a temporary IP address will be shown. It is advisable to set the same IP address the relay will be using for the Ethernet connection. Click OK. The next window will require the operating system file. Open it by using the dialog box. The next window will ask you to wait while the file is loaded. Then the program shows a message requiring you to switch the relay off and on again while the progress bar is in course to start the upgrading process. It is important to switch the relay off and on again during the time shown by the progress bar. In case this time expires or the relay is stuck after switching it off and on, the program will suppose there is an error in the serial connection and will show a window prompting the user to try again or postpone the process. If you postpone the process, the previous operating system and firmware will remain installed. Bear in mind that the serial COM port used in the boot upgrade procedure is the one selected before. After switching the relay off and on, if the serial communication between the EnerVista 650 setup software and the relay is correct, the program will show a message stating Setting Relay in Configuration Mode. The following window will require you to confirm you want to update the current version. Click Yes. At this point, the relay flash memory deletion will start. All the data stored in the relay will be lost. Up to now, no important change has been made to the relay or operating system. The memory upgrading process has just been prepared. This process can take some time, during which a progress bar is displayed. In the case of having some problems with the Ethernet connection, this process could be blocked. This is most likely to happen when above the progress bar, the label Sending File Image _ Kernel appears. At this point, the serial communication has already been tested, and it is imperative to finish the upgrade procedure to start working with the unit. If the procedure is not completed, the human-machine interface on the relay will show the message OS loading, and the relay will not start up. In this case, check the Ethernet communications and restart the process. Once the memory has been erased and the files upgraded, the next window will require the Ethernet communications parameters, the relay IP address and the gateway. These values must match the LAN structure where the relay will be connected. The relay IP address should have the first 3 octets corresponding with the gateway, and the last octet must be a free IP address reserved to the relay to avoid possible collisions with other devices. The gateway must be the one used in the LAN structure the relay is connected to. Momentarily, a window will state the default IP address is being set. And finally, one last window will inform that the operating system has successfully been updated. The F650 relay is now ready for use. IEC 61850 is a standard for the design of electrical substation automation. This standard defines the communication architecture, protocols, and data structures for substation communication and automation. This allows for horizontal or peer-to-peer communications. For example, protection relays that communicate between themselves using Goose messages. Goose is short for Generic Object-Oriented Substation Events. Vertical communication. For example, protection relays that communicate with a CCU or SCADA systems. Since IEC 61850 is an international standard, it is accepted among different relay manufacturers, which means that the F650 can communicate with any other IEDs that follow this standard. The F650 relay provides the capability of communicating with other IEDs, SCADA, or CCU systems using this standard. The programming of the IEC 61850 is done via the IEC 61850 configurator, which is PC software that can be launched from the EnerVista 650 setup software. The F650 61850 configuration file has a .iec extension. To open or create a new file, select File from the IEC 61850 configuration menu and click on Open IEC File from Disk. We can also download the default 61850 configuration file from the relay. This way, the user can make sure that they are using a compatible version of the file with the relay. Once the configuration file is opened, the user will have access to 4 different tabs. The first tab is ICD-CID. This is where all the communication settings and the IEC 61850 standard datasets available within the F650 exist. The second tab is Reports. This is where the user can define the information that the F650 will send vertically, which means that the relay will send these reports to a higher-level system, such as a CCU or SCADA. This information is sent via report blocks, which can be defined here. The third tab is Goose Reception. Here, the user can define the information that the F650 can receive from other IEDs. The F650 can receive information from up to 16 IEDs. The received information is mapped into remote inputs or remote Goose digital and analog inputs. The digital inputs can later be used inside of the relay to make certain decisions and can even be incorporated in the logic. The final tab is Goose Transmission. The Goose Transmission tab is where the user can define the information that the F650 will send to other relays or IEDs. We will learn about each of these tabs in more detail in the following sections. In this section, we will learn how to send information from the F650 using the IEC 61850 standard. The data can be sent via 2 main methods. 1. Reports. The F650 can generate buffered or unbuffered reports that can be transmitted vertically to a higher-level system. 2. Goose messages. This method is used to send data to other relays or IEDs. This kind of data transfer is used for horizontal communication. Reports. The F650 relay has some pre-configured reports that can be used for sending information to a 61850 client. These reports contain the main F650 information, but new ones can be configured if required. From the 650 PC software, open the 61850 configurator and select the Reports tab. In the Report Control block, we can see the reports that the F650 has configured by default. By clicking on any of these reports, Buffer, BRCB, or Unbuffer, URCB, all the information related with its configuration will be displayed on the right side of the screen. To configure a new report, right-click on the F650 icon and select Add Report. The program will ask whether to create a buffered or unbuffered report. If choosing a buffered report, the F650 will save or buffer the data in memory in case the Ethernet connection is lost, and once the connection is reestablished, the F650 will automatically send all data it has in the buffer or memory. An unbuffered report will not store any data in the memory. Next, specify whether to use an existing dataset or create a new dataset. For this example, we will create a new dataset. Select New Dataset and click Next. In this example, we will create a report that contains the protection current trip operations for the phase currents. First, let's change the report control block or RCB name and the report identification name. Next, we will create a new dataset and give it a unique name. In order to add elements to the dataset, select the item to be added by searching for it in the Dataset Sources menu. Then drag the items to the dataset. For example, we will look for the phase instantaneous over current element 1 and add the operation status. Let's add the operation for each phase and the general operation, which operates when at least one of the phases experiences an instantaneous overcurrent. In order to save this work, click on the Save IEC File to Disk icon and save the settings that have just been created. The IEC 61850 Goose allows sending and receiving digital and analog information. The digital information can be the status of flex operands, contact inputs, protection elements, or any other internal status inside the relay that needs to be communicated to another IED or system. The analog information can be currents, voltages, power, or any other analog value that the relay can measure. In this section, We will explain how to set up the F650 to send and receive Goose messages from other F650 relays or other IEDs. First of all, we have to enable the IEC Goose messages in the F650. To accomplish this, navigate to Set Points, Inputs Outputs, Remote Comms. Select Goose from the Value scroll-down window. Once we have enabled the horizontal communication, launch the IEC 61850 configurator. In order to program the F650 to send Goose messages, click on the Goose Transmission tab. On the upper left screen are the Goose TX control blocks, which define different options, such as the destination MAC address and the datasets. Recall that datasets are the information that is transmitted, including reports and/or Goose messages. Under the F650 icon, select the Goose Configurable control block. On the right side of the screen, notice the Goose TX properties, which define the Goose ID, control block name, and multicast MAC, among other options. The Goose ID has to be a unique name. This name cannot be shared with another IED that is sending Goose messages in the same network. Choose a unique name for the Goose ID. Next, we will learn how to configure the datasets. Similar to the reports, we can easily configure the datasets by first changing its name in the Dataset Properties window. Next, we will add Goose messages to be transmitted by dragging and dropping from the Dataset Sources window. In this example, we shall send some alarms via Goose messages. Another IED, such as an alarm annunciator, can receive these alarms via the Goose messages and display them on its screen. Traditionally, this has always been accomplished via copper wires. However, the IEC 61850 standard has helped replace a large amount of copper wire usually required in a substation. In the Dataset Sources window, expand the F650 data source icon, and then expand PHTOC1, which stands for Phased Timed Over Current. In situations of heavy load, the phase timed over current can indicate an alarm or even generate a trip if the overload is too much for the primary equipment to handle. Here, we will send the PHTOC1 operate flex operands and consider them as alarms. Similar to what we did for the reports in the previous section, drag and drop the op elements: General, Phase A, Phase B, and Phase C. Remember to drag from the Goose dataset sources and drop into the dataset elements. ICD files. In order to prepare the information that can be received by another IED or communication system, whether it is via reports or Goose messaging, an ICD file for each transmitting relay is needed. ICD stands for IED Capability Description. This file defines the complete capabilities of the IED, such as the IP address, report lists, and datasets. In order to generate this ICD file, go to File, Export.ICD. Or, alternatively, press on the Export ICD icon in the menu bar. The IEC 61850 configurator will now prompt the user for a location to save the .ICD file on the PC. This is the file that will later be used by other IEDs who want to receive information from this relay. We will now explain how to set up the F650 to receive Goose messages from other F650s or other IEDs. Click on the Goose Reception tab. The blank screen on the right is where the user can insert up to 16 IEDs which the F650 can communicate with. In order to add an IED that the F650 can receive Goose messages from, right-click anywhere in the canvas and select Add IED. The program will then ask for the ICD file of the IED to receive signals from. The ICD file contains the list of Goose signals that each IED can send. Once this file is added, then we can see the IED name and all the Goose messages lists it can send. Now we have to assign each message received from this IED to remote inputs or remote Goose inputs. Later we can use these inputs inside of the relay configuration or logic editor. It is possible to assign up to 32 digital statuses to the remote inputs, while the remote Goose inputs are divided into 32 digital inputs and 16 analog ones. To transmit the information of a Goose message to a remote input, click on the desired message and drag it to the mapping window to the left. Now the transmission of information from a Goose message to remote inputs is as easy as dragging and dropping the input that will be used. Inside the F650 relay, the remote input flex operands can now be used to generate logic.